This lesson is for Mrs. Cucci's College Now Pre-Calculus class. We are on lesson 7.6c, and we're going to pick up where we left off, talking about unit vectors. So when we spoke last time, we said that a unit vector let's call it vector v, remember that's bolded, can be written as 1 over the magnitude of vector v times vector v, or vector v divided by the magnitude of vector v. Okay, so we kind of peeked at that last time. So what we're going to do is we're going to actually see an example of how we can use that to determine how to use this unit vector. All right, so although unit vectors can have any direction, the unit vectors parallel to the x and y axis are particularly useful, okay? We can define them as vector I being 1, 0, and j being 0, 1, okay? Any vector can be expressed as what's called a linear combination. Of vectors I and j. Okay? So, for example, let's let a vector v equal v sub 1 and v sub 2. All right? Then what we can do in terms of this linear combination is we can look at vector v broken up into two components. Okay? V sub 1, 0, plus 0, V sub 2. Okay? So, essentially what this is can be rewritten like this, which is equal to V sub 1, I, plus V sub 2, J. Okay. Now, what's important about this is J is your vertical, okay, with a magnitude of 1, and I is your horizontal, also with your magnitude of 1. So it's broken up into your vertical and horizontal components, I being your horizontal and j being your vertical. Okay, so let's do an example. We're going to express the vector r as a linear combination of I and j. Okay? So again, we're going to kind of break it apart. Got that vector r. We know that equals 2, negative 6. So what you have is you have 2i plus negative 6j. Okay, it's just your first term, your second term. Your first is your I, your second is your j. So that's 2i minus 6j. So it's pretty simple to break that down into those components. Let's look at another example. We're going to write the vector q which is equal to negative I plus 7j in component form. Okay. So again, what we have here is q, and that equals negative I plus 7j, or negative 1i plus 7j. It's just another way to write it. So in component form, that's negative 1, 7. Okay. Let's take a look at another example. If vector A is equal to 5i minus 2j, so vertical and horizontal components, right? And B, vector B, is equal to negative I plus 8j. We want to find 3a minus b. Yep. Okay, so what we're going to do is we're going to take and we're going to find 3a minus b. So you take your 3 and you multiply it by the component a, 5i minus 2j, minus, since it's just b, we can say it's like having a negative 1, negative I plus 8j. So we're going to keep going. And again, these should be bolded, right? So what we have here is we have 15i minus 10j plus I, we're distributing through that negative 1, minus 8j. We're going to go ahead and combine my like terms. 16i minus, I'm sorry, I don't know why I thought this was, it should be a 6. My apologies. Negative 6 minus 8 is negative 14j. So there it is, broken up into your vertical and horizontal components. Okay, so the next thing we're going to talk about is direction angles. Okay, so when we're talking about directional angles, we need to think in terms of our unit circle. We are going to be using some trig here. Okay, so I'm going to draw in my unit circle. I know this is 1, this is 1, this is negative 1, and this is negative 1. Okay. So let's say I have some point P on my unit circle. Okay. And this is actually a vector. So a vector from the origin, so it's the terminal point P. And this is a unit vector because it has a magnitude of 1. Okay, that's the radius of the circle. We can actually take and denote this using cosine and sine. So this is actually, can be written as cosine theta sine theta, that point P. Okay. So the unit vector can actually be written in terms of sine and cosine. So we can say this vector u is equal to, in component form, cosine theta sine theta. All right, that unit vector. Or as a linear combination, with that I and j, we can write it as cosine theta I plus sine theta j. Okay, so either way, component or combination, linear combination. Okay? So the components of u are actually the functions of the direction angle theta. So this is your direction angle right here. Okay? And it's measured counterclockwise from the x-axis like we normally do, as it goes from 0 to 2 pi, or all the way around that unit circle. So we know that the formula of this actual circle is x squared plus y squared equals 1. That's just the formula of the circle. Okay? All right, so what we're going to do is we're actually going to learn how to find these direction angles. What I'm able to do is make that right triangle from here. This vector being my horizontal, that's my cosine theta I, right? That's my horizontal. And this one here is my sine theta I. So that's kind of where that all fits in, or sine theta j, I'm sorry. It's kind of where that all fits in, okay, where we're getting things from. Okay, so what we're going to do is we're going to calculate and sketch the unit vector. Okay. So we're given u equals cosine theta I. So there's your horizontal. This is a linear combination. Plus sine theta j. Okay. For theta equal to 2 pi over 3. This is the angle that we're given. We want to include the unit circle in our sketch. So here's what we do. Oops. We're going to take u, vector u, and we're going to take that angle of rotation, and we're going to plug that in for theta. So 2 pi over 3 I plus sine of 2 pi over 3 j. So again, your horizontal and your vertical components. And then what we're doing is we're simply evaluating. Cosine at 2 pi over 3 is negative 1/2 pi plus, and sine of 2 pi over 3 is square root of 3 over 2 j. Okay? And what the sketch of that's going to look like, based on our unit circle, is I know 2 pi over 3, right, standard position, is going to be about here. Okay? Theta, this is I. This is my vector u, and it should be ending right on that unit circle. I got a little crazy here. Sorry about that. Okay? And then this is your point, negative 1/2 square root of 3 over 2. So not very difficult to work with. It's just a matter of kind of breaking things apart. Okay. So now what we're going to do is we're going to let vector v equal v sub 1 and v sub 2 in component form with direction angle theta. We're going to use the definition of the tangent function so that we can determine the direction of the angle from component v. Actually, you know what? Let's skip this part. We'll go on to the next example. All right, so let's look at the next example. Let's determine the direction angle theta of the vector w equal to negative 4i minus 3j. Okay, so here's what we're going to do. We're going to take this and we're going to put it into component form, which is going to be negative 4, negative 3. Okay, and then we're going to take tangent. So this goes back to kind of what we've been doing, right? Tangent theta is equal to sine over cosine. This is our sine, this is our cosine. So negative 3 over negative 4. Take the inverse of that, tangent inverse of 3/4. And we find theta to be approximately 37 degrees. Okay, but since we know that tangent is positive in the first and third, we're going to have another possible angle, 180 plus that angle. Okay, or 180 plus 37 which is 217. So we get possible angles of 37 degrees or 217 degrees. Okay. Okay, so I think I'm going to stop there and leave the applications for the next day. So there is going to be a part D to this lesson. So again, come in prepared with any questions that you might have, and I will see you tomorrow.